Welcome to Electron. In the previous series of videos, we saw how to find maximization or how to solve maximization minimization problems using the graphical method. In this series, we're going to show you how to solve maximization problems using the Simplex method. And so this is called the Simplex method for standard maximization problems, because the way you do minimization problems is different, and then we still have the non-standard problems as well. So we're going to start with simply doing the maximization problems. And in order to understand how to do those, we're going to just simply set up an example and systematically work through the example through a series of steps of how to solve these problems. Later on, we'll show you some real examples with real problems, real text. Then we have to glean from the text the information we need to set up the problem. But let's assume that we just know what these things are, and we'll just go to the procedural steps to solve one of those Simplex method of maximization problems. All right, so the first thing you always want to do is you want to define your variables. Let's say you have two variables, you want to define what x and y are equal to. Could be the number of hours, the number of dollars, the quantity of each type, whatever it may be. So you want to define that. There may be more than two variables, so define all your variables. The next thing you want to do is determine what's being maximized. So here we know we're going to deal with a maximization problem, so we need to determine what that is. And let's say that we're trying to maximize the profit. So the next step is we want to determine what we call the objective function. So the objective is to maximize the profit, so therefore we need to have an equation that details what the profit is equal to in terms of your variables. So in this case, the profit is 2 times the quantity x and 3 times the quantity y. So you want to define that up front. The next thing you want to do is determine your constraints. The constraints were given to us that x plus y must be less than or equal to 5, and 2x plus 3y must be less than or equal to 12. So those constraints will determine how we can get the maximum profit. The next thing we'll want to do, step 5, is determine the equations with the slack variables, which is kind of interesting. What we do here is we have an inequality, and let's say that x plus y, let's say that both x and y were equal to 0, so what number would you have to add on the left side to make it equal to 5? Well, we say, well, let's add a slack variable, S1. It takes up the slack, the missing quantity. So if x plus y equals 0, then the slack variable would have to be 5 to make that equal to 5. So we want to turn this into an equation by adding an additional slack variable to then make it equal to 5. And we do the same with the second inequality. We're going to add an additional slack variable, a different one of course for the different equation, which will make this equation equal to 12. For example, if x and y were equal to 1, then we have 2 plus 3 is 5, and 5 plus whatever the slack variable is 12. So in this case, the slack variable would take on the value of 7. It is just simply there to force it into an equation from an inequality, and the slack variables then can take on whatever value you need to set it equal to the value on the right side of the equal sign. So then the next step is we want to rewrite the objective function. So we want to move everything in the objective function over to the left side and set it equal to 0 on the right side, which means that this now becomes minus 2x minus 3y plus the profit equals 0. Now we're going to take all that information and put it into what we call the augmented matrix. So this is where the Simplex method really starts. The augmented matrix is such that on the top here we write the variables x and y. We also write the slack variables and write the profit, and then we delineate it from the numbers that we have on the right side of the equal sign in the 3 equations that we've determined here, right? So we have 3 equations, 1, 2, 3. So we're going to have 3 rows, and on the right side of this line, we're going to write the numbers on the right side of those 3 equations. But here we write the value for x and the x, y, and the slack variables. So for the first equation, you see that the coefficient of x is 1, the coefficient of y is 1, the coefficient of the slack variable is 1, S2 doesn't exist in the first equation, P doesn't exist, and then here we have the number 5. The second equation, notice the coefficient is 2 for x, 3 for y. For S1, there's no S1 in the second equation, so that's 0. The coefficient of S2 in the second equation is 1. There's no P in the equation, and the number on the right side equal sign is 12. And the last row here, and again, notice the delineation. There's a reason for that, because here the equations that are derived from the inequalities, and on the bottom here is the equation derived from the objective function. And notice the coefficient of x is minus 2, coefficient of y is minus 3. There's no slack variables here, but we do have the variable p, so the coefficient there is 1, and on the right side we have 0. Now, what do those numbers mean? Notice that this here represents the profit, and at this point we have 0 for the profit. Also, these two numbers right here represent the value of any one of these variables on topic. This could be equal to x, y, s1, s2, or p. So let me go ahead and kind of put a little circle around that like this. And notice the value, the variable that will then be allowed to have this value is the variable that is associated with the column where you have a 1 and nothing but zeros for the other elements. So in this case, you can see that x and y must be 0 because they don't have a set of numbers here that are 1 and zeros everywhere else. So that means that x and y must be 0. But the slack variables, they have a 1 and zeros in the columns. So here you can say that S1 is equal to 5 and S2 is equal to 12. And then the profit here, because there's again 0, 0, and 1 here, the profit here is equal to 0. So the basic solution when you set up your first augmented matrix, the basic solution will then be x equals 0, y equals 0, because they don't have 1 and zeros in those columns. The two slack variables, S1 and S2, have values 5 and 12, and the profit at this point is equal to 0. That's your starting point. And obviously you don't want to end up there because that would mean you only have 0 profit. What you eventually want to do is you want to get the x and y columns to be 1s and zeros, if the problem allows you to do that. And then the slack variables will then go to 0, as these will no longer be 1s and zeros like this. And then you'll have a value hopefully other than 0 for the profit. So how do you go about doing that? Well, once you determine the basic solution, you're now ready to change the matrix so that you can solve for the proper values for x and y to give you the maximum profit over here. How do you do that? Well, now you look at these numbers down here. If these numbers are negative, you're not yet done. In other words, if these numbers are not 0 or positive, you have not quite reached your maximum profit yet. You pick out the column where the number is the largest negative number. Now we've got to be careful what that means. Here I'm saying that the negative 3 is a larger negative number than negative 2. Algebraically, negative 2 is bigger because it's closer to 0 than negative 3, but the way to express it would simply be negative 3 is a larger negative number than negative 2, so you start with this column. Now the pivot point where you want to pivot around will depend upon the smallest ratio between the smallest ratio of these two numbers divided by the numbers in the column you're trying to pivot. So in this case, you have 5 divided by 1 gives you 5, and you have 12 divided by 3 gives you 4. You take the row where the ratio is the smallest number. In this case, 4 is smaller than 5, which means you're going to pivot around that point. So now it's just like using the matrix method for solving equations. Of course, you want to make that into a 1 and everything else in the column into 0. So that's the normal procedure now. So to turn this into a 1, we're going to have to take row 2 and divide it by 3 and see what we get. So that's the first pivot. And now you just continue with the problem. So you continue, and when you do that, you go ahead and say, I'm going to take the second row and replace it by 1/3 the second row. So you're simply going to divide this row by 3 to make that into a 1. So then your matrix will become like this. So you leave everything else the same. So you get 1, 1, 1, 0, 0, and 5. The third column will be negative 2, negative 3, 0, 0, 1, and 0. And then the second row will now be reduced by a factor of 3. So we get 2/3, we get 1, we get 0, 1/3, 0, and 12 divided by 3 is 4. So now we have our pivot point right here. So let's go ahead and circle that. And now you want to get these two numbers to go to 0. So just like we do that with matrix operations, we're going to take the first row, R1, and replace it by the negative of that number times the row about which we're pivoting, row 2, and add it to the first row. And we do the same with row number 3. We take the negative of this number, which is a positive 3, times the row with the pivot number in it, R2, and then we add that to R3. And by doing this, we know we're going to turn those two into zeros. Then, of course, we also have to figure out what all the other elements in those two rows are going to change to. So let's go ahead and do that. Come up here. And our new matrix is now going to look like this. So the second row doesn't change because that's the one we're using to pivot around. So we have the 1 there, we have 0, 1/3, 0, and 4. Now, on the first row, notice that if I multiply this by -1, that becomes -1 added to here, I get a 0 there. So this definitely turns into 0. The same over here, if I multiply this by a 3, like I did, 3 times R2, and add it to this, I get 0. So this goes to 0. And notice that this is X, Y, slack 1, slack 2 in the profit column. So this, therefore now, I can say that the result of this will be that Y, because Y has 2 zeros and a 1, will equal 4 after this step. So that's an initial step. But we still have to take care of everything else in the rows. So now we're going to take minus R2, so minus this, and add it to this. So minus 2/3 plus 1 gives me a 1/3. So this becomes 1/3. Notice minus 1 times 0, nothing changes. Add to 1, that still stays as a 1. So we have minus 1 times a third added to 0 becomes a minus 1/3. Here we have 0, 0, so nothing changes. And here we have minus 4 added to 5 becomes 1. For the bottom row, I have 3 times 2/3, that gives me 2. Added to minus 2, that gives me 0. 3 times 0 added to 0 gives me 0. 3 times a third, that's 1, added to 0, that gives me a 1. And 3 times 4, that's 12, added to 0, gives me 12. Oop, and I forgot the zeros here. 0, 0, 0, this is still a 1 there. All right, so the 1 doesn't change because 3 times 0 plus 1 is still a 1. Okay, so now I have my new matrix, and what has changed now? Notice from this, I determined that X is still 0. Y is now equal to 4. I can see that slack variable 1 is equal to 1, S1 is equal to 1, and S2 is equal to 0, and the profit is now equal to 12. So that's an intermediate value, or an intermediate solution. Now, could I go on and continue with this? Well, I potentially could do that, but notice I no longer have zeros here, which would indicate I probably have reached my maximum profit. If there were still zeros here, I probably didn't reach my maximum profit. But what this is telling me is that if I produce 0 of X and 4 of Y, I will get the maximum profit. So coming here to my objective function, if I want to plug that in and see what we get. So my solution here is my profit will be equal to 2 times, well, X is equal to 0, plus 3 times Y, which is equal to 4, and that gives me a profit of 12, which is what I got down here. Notice I still have a slack variable, S1 equals 1, which means I didn't utilize full capacity. As long as the slack variables did not go to 0, there still is room for potential improvement in the profit. So let's see what we can do now. So what we're going to do, just to check it out, is we're going to pivot about this point right there. And notice that if I go ahead and do my ratio, I unfortunately didn't leave a lot of room here. I take 1 divided by 1/3, 1 divided by 1/3, that's equal to 3, and 4 divided by 2/3, that's equal to 6. So 3 is a smaller number, so if I pivot around this number, see what I get. So even though I probably have reached maximum profit, I want to see what happens when I go ahead and pivot around here and get a value for X if possible. So let's go ahead and work that out. Well, to make this go to a 1, I'm going to take the first row and make it 3 times the first row to turn into a 1 and see what we get in our augmented matrix. So the first row then becomes a 1, a 0, a 1, a minus 1, a 0, and a 3. The next row stays the same, 2/3, 1, 0, 1/3, 0, and a 4. And then the final row right here is a 0, 0, 0, 1, 1, and a 12. Now, notice what we need to do in order to get this column to go to a 1 and all zeros. I just simply have to take care of this. This is already okay because I have a 0 there. So what I'm going to do is I'm going to take the second row and replace it by the negative of this number, negative 2/3, times the row with the pivot in it, that would be row 1, and add it to row 2. I don't have to do anything to row 3 because that's already a 0, which would indicate that the profit is not going to change, but the value for X is going to change. So let's see what happens. Well, let's go ahead and operate there and see what we get for the matrix. So row 2 is not going to change. Row 1 is not going to change, so we get 1, 0, 1, negative 1, 0, and 3. Row 3 is not going to change, 0, 0, 0, 1, and 1, and 12. Now, what happens to row 2? Notice, negative 2/3 times 1 is negative 2/3, plus 2/3 gives me 0, which is what I wanted. This will still be a 1, that won't change. Now, negative 2/3 times a 1, that's negative 2/3, added to 0 gives me negative 2/3 right here. Negative 2/3. Let's see. Oh, let me go back here. Negative 2/3 times this, added to 0. Yeah, that will be negative 2/3. Negative 2/3 times a negative 1 is 2/3, plus a third is 1. Negative 2/3 times 0, that still gives me 0. And negative 2/3 times this gives me negative 2, added to 4 gives me a 2. Notice things have changed a little bit. Now, let's plug in, let's put on top here x, y, slack variable 1, slack variable 2, profit. Okay, so we determine now that x now has a value. X will now equal 3. Y will now equal 2. S1 is equal to 0. And S2 is equal to 0. Why are they 0 now? Because they no longer have a 1 and all zeros in those two columns. So we've eliminated the slack variables. Profit is still 12. So notice that our profit didn't change, but the values for x and y did change. So now let's plug those two values back into our objective function and see what we get. So the profit is going to be equal to 2 times the value for x, which is 3, plus 3 times the value for y, which is 2. Notice 6 plus 6 is 12. Again, we get the same value. Profit is 12. And notice, even though we now have a different way of operating, so we found the maximum profit when we let, where are we here? When we let x equals 0 and y equals 4, but we got the same maximum profit when we let x equals 3 and y equals 2. So there's two possible ways in which you can gain the maximum profit, letting x equals 0 and y equals 4, or letting x equals 3 and y equals 2. Either way, you get the maximum profit. So this is how we use the standard method for standard maximization problems using the Simplex method, and it's really slick. It really works well. It seems a little complicated, but after you've seen a few examples, it's really not that bad, and it gives you the correct answer all along, and you can see how the problem develops and how the values for the variables and the slack variables change and how the profit builds up as you go through the process. Now what may happen is if you continue doing the process and you keep pivoting and the profit number goes down again, you've gone past the maximum profit, you probably want to stop saying, oh, now my profit drops, I want to go back to the condition where I found the maximum profit. So again, simply go through these steps, define the variables, determine what's maximized, determine the objective function, determine the constraints, then change the constraints, which are usually inequalities, into equations by adding slack variables, then rewrite the objective function, then take the equations with the slack variables and the objective function rewritten, put in an augmented matrix, then determine where you want to pivot. It's always the largest negative number on the vertical and the smallest ratio on the horizontal, where they come together. You turn that into a 1, everything else into zeros, and then you simply follow that method until you've turned these into positive numbers or zeros, and you have values for your important variables x and y. And that's how you use the Simplex method to solve standard maximization problems.